So for this problem it says, a football is thrown straight up in the air and stays in the air for 4.5 seconds. What is the maximum height that the ball reaches? So it doesn't look like we're given too much information here, so let's just draw the problem and see what it's asking. So basically we have a ball being thrown up in the air, it reaches a maximum height, and it should fall down on the ground after that then. So let's just draw out the problem then. So initially it's being thrown from the ground. So we could say that our di is going to be 0. And then it's going to be thrown up in the air, and it's going to reach some maximum height. So that maximum height is what we want to actually determine. So we want to find the maximum height, which we can call df. So that's the final position. So this problem gives us the time that it's going to stay in the air. So basically it's going to go up in the air, reach maximum height, then go down on the ground. So that whole entire time is going to be 4.5 seconds. Well, to reach its maximum height, that's going to take half the amount of time. So it takes half the amount of time to reach the maximum height, and then the other half is going to be it falling down to the ground. So the time that we'll use, the variable t, will be half the time that we're given here. So let's write down what we're given then. So we're given time t, and it's going to be half the total time. So t is going to be 2.25 seconds. And we're also given di, and we don't know df, so that's going to be our find variable. So what else are we given now? So we know the ball is going up in the air and they're reaching some maximum height. So we're going to have the acceleration of gravity acting downward on the ball. So we know the acceleration of gravity is going to be negative 9.81 meters per second squared. And like I said in the last video, it's negative because gravity is acting downward. So we're given anything else? Well, when the ball gets thrown up in the air, once it reaches its maximum height, right before it starts moving downward again, the velocity of the ball is going to be 0. So it's being thrown with some initial velocity, vi, which we don't actually know yet, and it's going to reach the maximum height. So when it's at its maximum height, we call that the final velocity. So we call that vf. So we could say vf, the final velocity, is going to be 0. And again, we're choosing that as our final velocity because we want to know what the maximum height is. So that does it for everything we're given. And I'll write down the find down here actually, so we have room to write out the problem. So we're trying to find df, which is the maximum height that the ball is going to reach before falling down. So let's look at our equations here and see what we can use. So we know t, we know di, we know a, we know vf. We're trying to find df. So there isn't one equation in particular that has all these variables in it. So we can pick two equations and then solve the two unknowns that we have. So let's look for one that has df in it though. So this one right here has df, which we're trying to find. So we know di, we know t, we don't know vi, and we know vf. So things we don't know in this equation are vi and df. So we're trying to solve for what df is. So if we could find vi, then we could solve df because we know everything else in this equation. So if we look at this equation here, we know VF, we know A, and we know T. So that means we could solve for what VI is. So we solve for what VI is, and then we use the equation for DF by plugging in VI from the first equation, whatever that result is, and then solving for what DF is. So very similar to the last two problems. So let's do that. So let's start with the VF equals VI plus AT equation. So like I said, VF is going to be 0. So we'd cross that off. And we know A and T. So let's solve for what VI is. And now let's just plug in the values for A and T. So if I put this in a calculator, I'm going to get 22.1 meters per second. So it gives me the initial velocity. And the initial velocity is going to be positive because the ball is being thrown upward, and upward's positive. So we now have VI. So we can use the second equation, plug in the value for VI, plug in all the given values, and then solve for DF, which is the maximum height. So we could cross off the values that are 0. So DI is 0, and VF is 0. So let's just write out what we're left with then. So we're just left with T over 2 times VI. So now we can just plug in the values for T and VI. So now if I put this into a calculator, I'm going to get 24.9 meters. So 24.9 meters is going to be the maximum height that the ball reaches.